Thank you everyone for joining. My name is Shanisa Cambrick. I'll be the MC for this room for today. A couple of housekeeping notes before we get started. The first is I want to thank our gold sponsor, Delve Risk. So Delve Risk is a market research and data brokerage firm, and they are happy to support our CloudSec community. The second thing is, if you have questions, please do post them in Slack. We will monitor the Slack throughout the session, try to answer questions throughout the session. Anything we don't get to, we'll answer at the end. Thank you. And over to Jared from Synthesis to talk about Enterprise Cloud Journey.
Hey everyone, and welcome to my talk today. I'm going to be talking about the Enterprise Cloud Journey and lessons that we've learned taking many organizations to cloud. Just a quick introduction, my name is Jared Naude. I'm a senior cloud architect. I specialize in security and enterprise cloud architecture. My research interests include privacy, security, and disinformation. I personally started using AWS in 2013, and I work for an AWS partner based in South Africa that serves the financial services and retail sectors. My Twitter handle is @JaredNaude, and in this talk I'm going to share our journey, our wins and fails, and lessons that we've learned across multiple AWS customers as we've taken them through their cloud journey. And I'll do so by contrasting what it was like building on AWS 5 years ago versus today with all of the new services that have been announced in this period. Just a quick history, AWS first launched in 2006 where S3 was available and a number of other services were then announced, and this was really the era of the startups. Thereafter, a number of services like Elasticsearch and Lightsail were announced that were really intended for kind of the small to medium sized businesses, but it wasn't really quite enterprise ready just yet. It wasn't until 2017 when AWS organizations became a thing with additional services like Guard Duty, Transit Gateway, and Control Tower that really lent themselves to the enterprise market. When we started on this journey in 2017, we had to figure out which region to use, and we did this in conjunction with our customer. We looked at South America and Australia, and they were quickly ruled out because not only were they quite expensive, from a latency perspective, they were really slow. Asia Pacific was also excluded due to the geopolitical issues that are in that region, and we couldn't use a US region due to the Patriot Act. There was a huge concern about the federal government getting access to our customer data. Eventually, Ireland and Frankfurt were chosen, where Ireland was the primary region and Frankfurt was the DR region, and this is a decision that many of our customers here in South Africa have chosen to go with. Back in 2017, the idea of giving your data to another provider, especially a cloud provider that sits outside the country, was really something that was quite scary to many people. However, in 2018, our regulator, which is the South African Reserve Bank, actually put out a directive which allowed banks and enterprises to offshore their data, including the use of cloud technologies, and this also included secret customer data, so long as the correct permissions were in place. When we looked at the control objectives that we needed to put in place from a cloud perspective, we looked at a number of various controls and frameworks, as well as the local banking and privacy laws, as well as those laws in Europe as well. And from that, we identified 700 control objectives, of which 300 were technical control objectives. 130 of these control objectives were covered by AWS as part of the shared responsibility model, and this would cover things like physical security, fire suppression, etc. And 170 of those controls required engineering, where we as the customer and the cloud team would actually have to go put these controls in place. When we also looked at what could be migrated to AWS, given that we are based in South Africa and all of our workloads will be based in Ireland, there is a significant latency impact with that. We kind of looked at various banking systems, and on the slide I kind of show these various systems from core banking to primary and secondary systems, as well as peripheral systems. Now, from a risk and innovation perspective, on the peripheral systems, this is where a lot of the innovation would typically take place. When people think of innovation inside a bank, it's typically in the peripheral systems. From a release management perspective, core banking only has 2 or 3 releases per year, which makes that kind of change really difficult and very risky, because if one of those systems were to go down, that has a very huge reputational impact for a bank. However, in the peripheral systems, they have a lot of releases per year, so it makes it a lot easier to kind of move that into cloud. And the latency requirements for these peripheral systems are not as intense as they are, for example, in core banking, where an organizational level agreement typically requires that these systems respond within 100 milliseconds. So once we knew what we were going to do, we started building out our network infrastructure. And at the time, you had to use transit VPC, since transit gateways were not announced yet. And at the time, the recommended pattern was to use the Cisco CSRs. We never had a lot of luck using the Cisco CSRs. We found them to be quite unstable. Tunnels would routinely go down. And as a result, we actually moved to a different firewall appliance. And in the process of doing this, we were actually astounded by how many firewall vendors, especially reputable firewall vendors, provided CloudFormation templates that did not adhere to AWS best practices. So they would typically create infrastructure in a single availability zone. The security group configurations were open to the entire internet, including exposing ports that were not needed for the appliance. The management interfaces were exposed, and in many cases they would use default passwords that were easily guessable. And when we got these templates, often we would rewrite them in Terraform. And when we actually set up the infrastructure, if we had any problems, a lot of the vendors would actually say, well, sorry, you didn't use our template, so we're not going to help you in any way, which we actually felt was rather inappropriate. So the big lesson here is to always check your templates before you create them, and don't blindly trust vendors. The next thing we had to address was network automation, where whenever we created a new account, we had created a VPC, and we wanted that VPC to automatically join the transit VPC. And we did this by having a number of lambdas, and the lambda would create information in an S3 bucket, which would then trigger a workflow for the lambdas to go run shell commands on the firewall to do the VPN connection, as well as to update the various route tables. A lot of engineering time went into this automation, and the solution was we reworked multiple times due to the complexity. However, we were never really able to have it highly available and to do automated failover due to this complexity. And one of the challenges that we had was the protocols typically needed for high availability are not routable in AWS. One of the other challenges was that from an API perspective, a lot of these appliances only expose a limited amount of their functionality through the API. This has improved recently, where multiple vendors actually allow various tools like Ansible and Terraform to be able to configure their appliances. One of the other things that we failed with was how we managed routing and IP addresses. When we started this, whenever we created new accounts, we had dev and prod directly next to each other from a CIDR perspective. This was a very big mistake. We should have separated that. And also what we did is each time we created a new account, we would then do an announcement for that specific block instead of announcing the full block inside the bank's network. And because we did this, this lent itself to actually various mistakes. And we actually had an issue one Friday afternoon where one bad route announcement had a typo in it that caused a data center to go offline for 32 minutes. Luckily, this specific data center and the way that the network was configured at the time limited the impact of it, but it was still a massive wake-up call to the network team at that point. One of the key lessons out of that was really to make these large route announcements, but then also to really separate the environment into different CIDR blocks, and then that allows easier configurations from a security group perspective, as well as from an isolation perspective as well. When Transit Gateway was announced at reInvent 2018, we jumped at the opportunity to use it because it's a lot better than the Transit VPC solution that we were using. It's fully managed, it's highly available, and there's massive cost savings over using the Transit VPC solution that we were using. However, very quickly we started having questions around, how many transit gateways should we use in our environment, and whether we should use separate transit gateways for different environments. However, if we have, for example, a non-prod VPC that needs to talk to a prod VPC, how would that be done? And we actually have split opinion in our company on this specific topic. Our team has actually also adopted another mechanism where they actually create multiple route tables to actually segregate the traffic. So routes that are allowed will be added to the route table, and effectively what happens is the route table kind of becomes a firewall in an indirect way, because if a specific route is missing, traffic wouldn't be able to move there. And I would like to hear from everybody, kind of how they kind of approach this problem in their organization. One of the interesting things was in 2017, we never had Direct Connect or CloudFront available in our region yet, so many of our customers, our banking and enterprise customers, would use lease lines to talk to their various partners and integration points. A lot of these networks run on fairly complex and expensive MPLS networks that tend to be unreliable and slow in some instances. And in order for us to use AWS at that time, this was about $1 million for the lease lines per year, which was actually relatively expensive. On a slight tangent, in 2011, our government actually announced various fiber subsidies for various private companies to expand broadband access in our country. And the way that this was done was that significant dark fiber was rolled out throughout the country, where multiple network operators could sit on top of that with the principle of open access. So all of these networks would be paired with one another, and then internet service providers could offer their services on top of that. So depending on what metro network you are on, you could actually get a choice between 10 and 30 different internet service providers. And this laid the groundwork for actually AWS to come to our country, where at the end of 2017, they actually announced Direct Connect and CloudFront, which was available in a specific co-location facility in our region. As part of this process, a lot of banks, enterprises, and other vendors actually started redefining their network edges, where they would actually extend their network edges into the co-location, and this had a number of interesting benefits. For example, these enterprises and vendors could integrate with each other at this co-location facility. There was a lot of cost savings as a result of this, as well as latency benefits. But it also meant that if they wanted to use AWS, they are now available in the same facility as well. One of the challenges that we had from a network connectivity perspective is how do we allow on-premise infrastructure to access managed AWS services through the Direct Connect. We always tell our customers to never allow the BGP communities that are available on the Direct Connect to come into their environment, because unfortunately many security engineers and architects don't fully understand the risks of doing so. Data exfiltration is a massive risk that could occur if you were to do something like this. And without the correct monitoring and controls in place, if data was actually exfiltrated, it would be very hard to actually detect that. And really what you want in this scenario is a solution where you can choose which service can actually communicate to a managed service through the Direct Connect. One of the potential solutions for this is to actually do traffic inspection and offloading at the firewall before traffic moves over the Direct Connect. This has a number of problems. One of them is the adoption of TLS 1.3. Because it has perfect forward secrecy, it's very difficult to break that connection and to do out-of-band monitoring. You can use things like session key forwarding, but there's some additional complexities with doing that. Some NDR solutions can monitor the traffic without having to decrypt it, but again, that can be quite expensive. And then if you are going to do traffic inspection on the firewall from a regulatory perspective, we need to think about the type of data that is moving over the specific connection. So it's likely to contain secret data, and from a regulatory perspective, if you are going to inspect that from a key management perspective, that has to be done with an HSM. So now if you have multiple 10 gigabit links, you now need very expensive hardware to be able to do that inspection, but then also to be able to do the key management in a way that is compliant with our regulations. And then with all of that hardware, you may actually get some complexity when it comes to things like link aggregation groups and LACP configurations with all of this clustering. An interesting thing that we've actually seen with one of our newer customers that have a newer topology where the routing and switching layer is somewhat segregated compared to the old model where exit points are kind of known in the entire environment. With this customer, they are actually able to address this issue by basically deciding on the routing layer which of the servers and VLANs can actually use the direct connect and send all of the other traffic through the proxy. We thought this was quite a neat way to actually solve this issue. When we started our journey, in 2017, we really wanted to ensure that we created a secure environment. And what was very important to our customer was that AWS would be faster than on-premise. So to get a virtual machine on-premise would take 6 to 8 weeks, and the goal was to make sure that we could actually beat that. When we started this journey, an account would typically take 4 to 6 weeks to be created and connected. And as time went on, we managed to get that down to 1 or 2 days. Before the landing zone construct actually came out, we effectively had our own kind of landing zone with all of the respective controls. However, one of the mistakes that we made is we actually kept logs actually in the account as opposed to actually putting it in a separate log archive account that the landing zone and then eventually control tower would actually do. When we look at AWS from a risk perspective, it's really important to understand that cloud is very different. The operating model is very different from on-premise environments, and if an organization takes their legacy on-premise workflow into the cloud, they won't actually be very successful. Application teams should also have more freedom and responsibility in this environment, but that can also lead to potential misconfigurations, which can lead to very serious security issues. And one of the goals that we want to achieve when we assist people on their cloud journey is to really change ownership from this kind of old model where you had a build and a run team to more where the application teams take control of not only the engineering but the operations of the various applications as well, and the cloud team would look after the platform. As you mature through this journey, what should happen is the application team should take more ownership of the cloud platform where they can engineer various capabilities, etc. on the platform. And one of the issues that we see is that many organizations, they only see the end goal of being in cloud using DevOps techniques, but they don't think of the journey that they need to take the organization through to actually achieve that. When we started with our IAM journey in 2017, we were in a predict and control model where we created policies that we thought developers would need. This made it very difficult to add new services as they were released, and developers were not able to create their own IAM policies due to the risk of privilege escalations. So the cloud team had to effectively manage all of these IAM permissions, and this didn't really scale well. In 2019, we actually changed this model to a trust and verify model where permission boundaries allowed us to give teams permissions to create their own IAM policies, but we could restrict the permissions that they could give those policies that they created. And then using this combined with Access Analyzer and various third-party tools, we could ensure that we had compliance across all of our AWS accounts. From a federation perspective, we started doing this with ADFS, and one of the challenges with this is if you have 1,000 AWS accounts, you need to have 1,000 IDP configurations and certificates, and whenever those certificates expire, you then have to go rotate 1,000 certificates, which is not great. You also need third-party scripts for developers to be able to get their access keys when using federation, which is not great, and this is actually end of support from Microsoft. In 2019, we switched to Azure AD IDP initiated SSO, where we would use Azure to basically federate into AWS, but this has the same issue. If you have 1,000 accounts, you need 1,000 IDP certificate rotations as well as 1,000 Azure AD enterprise apps. One of the problems with doing this from an automation perspective is that you can't actually create an enterprise app using the API because that functionality is not available. So you actually have to create that app manually, which is not great from an automation perspective. And again, you would need third-party tooling to allow developers to actually pull the access keys when they are actually federating using these roles. At reInvent 2019, AWS announced additional functionality for AWS SSO, where you could use an external identity provider like Azure AD or Okta. What this meant is that if you have 1,000 AWS accounts, you only need one IDP certificate rotation and only one Azure AD enterprise app. And because the web browser natively allows developers to get the access keys, you don't need to have additional third-party tooling to enable that. One of the challenges that we had from a self-service perspective, we had a lot of tension between the cloud team and app teams when enabling them for self-service. As I mentioned, from an IAM perspective, we were highly restrictive of what we would allow them to do, but also the fact that the cloud team had to then create additional IAM policies because they were not allowed to do that. So what we eventually came up with was this traffic light model, which allowed us to enable self-service, to identify high-risk services and actions and block those from application teams. And then we also then created a process to allow new services to be released to these application teams as they were announced by AWS. And this also made it a lot easier to communicate what was allowed and what wasn't not allowed in our environment. So in this traffic light model, we have a number of high-risk services which only the cloud team can do. This is things like networking and internet gateways, which we absolutely do not want the application teams to touch. We have medium-risk services, which are not by default allowed in an environment. Teams can apply to get access to this, and depending on the skills in the team, a decision will be made as to whether they can use those services. And then the green services are allowed by all application teams. And we use a combination of permission boundaries and service control policies to actually enforce this across the organization. Whenever a new service is announced by AWS, it starts in the red block where it gets reviewed, and then over time it will move to the green block so long as no risks are identified by the team. From a service risk perspective, whenever we look at a new service, we look at the use cases, how it fits into the VPC construct. Does it use VPC endpoints? Does it support resource-based policies? What does a good configuration look like? What happens if it's misconfigured? How could it be used for data exfiltration? Are there any potential licensing implications of using it? And what are the mitigation steps for any risks that are identified? One of the ways to operationalize this properly is the idea of componentization. So developers don't need to be experts in the services that they are using. What can happen is the cloud team and eventually application teams can actually build secure configurations for different services, and they can then build higher end modules with that where they can address various use cases and then make that available for the rest of the organization to consume. One of the things to really understand when you go through the cloud journey is that as you go through this kind of migration is to understand that IT pros, and for a lack of a better term, these are the kind of old school IT people that are used to doing things on the console. You really need to enable them to be able to do this configuration through code and infrastructure as code in the organization. What you should also realize is that developers are really bad at infrastructure, so you really need to make a concerted effort to allow developers to create these various modules, but also allow IT professionals to be able to support the developers in that process by making sure that whatever is created is actually secure and is reusable for the organization. One of the key things to actually enable this is to ensure that your code management, regardless of what platform, whether it's GitLab, GitHub, Bitbucket, etc., is actually managed properly. One of the things that can really derail infrastructure as code adoption in an organization is a very poorly thought out repository management process. And what you really want to do is have the cloud team enable the application teams, but also create modules that the application teams can consume. And over time, as you get better with your maturity, the application teams can also then start committing to various modules that can then be reused by other application teams. And this is one of the key things that can help you scale in an organization. And as these various modules are created, they need to be reviewed. So the way that this should occur is through an architecture review board. This is one of those other things where we've seen that organizations that don't have architecture review boards, they tend not to do as well in cloud than those organizations that do have these boards. And the purpose of the architecture review board is to provide guidance and insight and approval for various architecture patterns. And this can really set the tone for the rest of the organization, as well as to prevent bad architecture from actually going into an organization's cloud environment. The team members that should make up the architecture review board include engineering, risk, security, architecture, and operations, as well as any additional team members that are required. Many of you would be familiar with the shared responsibility model. One of the things that we found very useful is to actually expand this, where you actually make it very clear what the responsibilities are of the application teams, what the responsibility of the cloud team is, as well as AWS, and then to split that appropriately. For example, in the cloud team, that would typically comprise of core engineering, networks and security, etc. The other win that we found was actually creating a welcome pack. So you can't assume that developers will be psychic and know what they need to do or what they are not allowed to do in AWS. So the welcome pack really allows them to kind of know what is and what isn't allowed. And this should also include things of where to get help, what workloads are in the environment, various architecture decisions, where to get modules, etc., and various important decisions that have been made regarding a specific cloud environment. For example, any third-party services that the organization is using. And all of this should fit part of a scaled learning model in the organization. So scaled learning is effectively how do you take all of this knowledge that you have in your organization and actually spread it effectively across the various teams. And this would include how to do things from a privacy, security, and regulatory perspective, where to get help, where are the web portals to request various things, how to, where to go get guidance on other potential issues that you may be having. And all of these things effectively form part of the operating model. And if you don't have these things in place, often what we've seen with many organizations is that this leads to an ineffective operating model where as they go to cloud without having all of these things in place, they typically stall on their journey and they don't really scale appropriately. So in order to scale and optimize appropriately, you really do need an effective operating model. The other thing to keep in mind during this process is that operational excellence is always better than technical excellence. You can have the best golden horse for your organization, but if you can't run it, it's not going to matter. Moving on to some key risks that we've identified. One of the things that keeps me up at night is the capability and ability to do large-scale data exfiltration outside of AWS. If an account is compromised, various functionality of AWS like RDS, EBS, DynamoDB snapshots can easily be shared to an attacker's account if they have privileged access into an account. Buckets can easily be replicated outside of the environment. An EC2 instance that is compromised, data can be exfiltrated from S3 buckets using VPC endpoint or even potentially directly to the internet. And this is really something that you really need to be aware of when you are using AWS. One of the key wins that we actually had on this journey, we had a requirement from a customer with that the security team wanted to manage all of the KMS keys, and they wanted to have a clear audit trail of how these keys were being used. So what we did is we put all of the KMS keys in a central account, and then we used SEP to block the creation of new KMS keys in a specific application account. And what we didn't realize at the time was actually how effective this was from a data protection perspective. So if we go back to that exfiltration risk, if keys are in a specific AWS account and only IAM roles, etc., in a specific application account are allowed to use those keys, even if an attacker gets privileged access to an account, they wouldn't be able to actually exfiltrate that data, because they wouldn't be able to change the key policies because those keys are outside of the account. This is actually probably one of the best data protection things that we've seen that is fairly easy to actually operationalize. One of the other things that we found to be very beneficial is this idea of game days. So game days are basically a day where you invite a group of individuals, and then you can maybe run through various exercises from high availability, etc. One of the game days that we like to do is we actually invite a small group of people, no more than 15 people, and then we run various exercises with them. One of the exercises that we found most useful is what you see in the slide here, where an application team needs to get an encrypted object from an S3 bucket. But in the account that we give them, we break the VPC, we break the root tables, there's permissions that are missing or misconfigured or are spelled incorrectly. The resource-based policies on the KMS key and the S3 policy is misconfigured. And then we also teach them how to use CloudWatch logs and CloudTrail to actually be able to figure out what's actually going on. And what's very interesting or somewhat alarming is actually how many engineers are actually unable to actually complete this challenge. And it's a fairly simple thing to actually do, and it can actually teach engineers quite a lot as you kind of go through this process. One of the other interesting guardrails that we put in place is from a hardened AMI perspective. Before Image Builder was a thing, we used Jenkins and Packer to build images with various agents and hardened configurations, and we would share that out with application teams. Back in 2018, you couldn't share encrypted AMIs, which you can do today. This made the automation a little bit tricky. And at reInvent 2019, Image Builder was eventually announced that it was missing some key features, but over the year, these features were added, and we are now using Image Builder to actually build out these AMIs as well. From a security automation perspective, we've tried many various initiatives to try automate various security components. One of the things that we've had mixed results with is taking guard duty alerts and then acting on them. What we found is that guard duty sometimes raises false positives, and if you just automate alerts automatically without having that being reviewed, you can actually cause some issues for yourselves. One of the challenges as a defender is actually doing security automation with various tools and appliances. So if we had to, for example, actually onboard an asset and you need to follow a 10-step process, what we've often found is that many software only exposes a limited part of that workflow via the API. So for example, if you had to onboard an asset, the first 3 steps of the 10-step process must be done via the console, and the rest can be done via the API. This is super frustrating. We've also found that in many cases the API documentation is not great, and also from a licensing perspective, once you onboard an asset into whatever tool or capability you're using, that automatically assumes and consumes a license. And if you are using autoscaling groups, for example, this model causes a lot of issues very quickly. One of the other issues is this idea of a single pane of glass. While many architects would love to see have a single view of their tooling across on-premise and cloud. And while many vendors would promise a single pane of glass experience, many of them are actually fail to actually deliver on that. So as a result, one of the lessons we've learned is that you should always try use cloud native tooling as far as possible. Sometimes it doesn't always meet the requirements that you need, and in that case, then only should you go look at third-party tooling, but be very wary of using kind of tooling from the on-premise world in the cloud, because you're going to have a bad time. One of the other lessons that we've learned is with the various marketplace risks. So software that's available on the marketplace may not always be the latest version, and often a vendor will have the latest version available through their download website or through their various repositories, and often that lags quite behind of the software that's available in the marketplace. Also, if you're using software that has a tiered licensing model, you may not actually get the full benefit of that if you have multiple subscriptions across accounts versus one single consolidated subscription. What we've also seen from a legal perspective is that if you allow your application teams to use the marketplace, they could actually be agreeing to end user license agreements that may actually go against some of your company's policies, but could also cause legal issues where if you have if you do a POC with a specific vendor and that vendor only allows a single POC for the organization to take place and multiple application teams are actually doing this POC, you could actually be breaking that end user license agreement with the organization. So you might want to think of restricting marketplace access across your organization as a result of this. Another thing to keep in mind is that not all regions and availability zones are equal. If you look at the region table, you'll know that some services are not available in certain regions, and certain regions really do have capacity issues. We've actually experienced this with the new region that's available in our country, and not all availability zones are actually created equally. If you followed the What's New blog recently, you would have seen a few instances where services have been expanded to previously unsupported availability zones, and that really indicates, how these availability zones are not created equally. In closing, I would like to share two of my wish list items. One of the challenges that we have with our application teams is how do we actually test that infrastructure and services are actually highly available. In the legacy on-premise world, DR can easily be tested by people actually physically turning off power and unplugging network cables. However, you can't really do this in AWS, and it would be great to have a feature where we could per an account or per an organization, a unit basis, actually shut down an availability zone and actually make sure that the services that are running in our accounts are actually highly available as they should be. Another wishlist item is Azure Sentinel for AWS. So Azure Sentinel is a great monitoring tool. It would really be great if AWS could announce something like that that we could use. So what this would do is it would collect the various logs, CloudTrail, VPC flow logs, S3 logs, app logs, and then allow application teams in the account to be able to search through that various data, but then have the functionality where all of this data can be ingested into a central security account, similar to the way that GuardDuty or Security Hub works. It would be really great if something like this were possible one day. And in closing, I'll just mention what's next for us. We are kind of looking at how we could potentially use enclaves, and with the recent announcement of AWS Network Firewall, kind of looking at how we can use it to actually better our security capabilities and offerings for our various customers. And with that, I would like to say thank you very much and happy to take any questions. Please do provide feedback in the link below that is available at bit.ly//CS21-NAUDE. Thank you very much.
So if you have a question, if you could put it in the Slack channel, that way I can read it out for those that are streaming. We do have one question. Will the slides be available Will you make those available to us?
Yes, I will put them out somewhere and then tweet out the link later today.
Okay, thank you. The next question is, did you happen to test if CMK usage had any impact on things like S3, pre-signed URLs for object access?
There is a way to do that. I can't remember the exact technical details, but there is a way to actually use CMKs with pre-signed URLs. You just need to get look at that on the KMS documentation.
Okay. And then I had one question from my end. You mentioned a bunch of different compliance frameworks. Which one did you find the most challenging to adhere to?
Actually, all of them, to be honest. One of the big challenges is from a regulatory perspective, especially from those frameworks, is that a lot of them are very similar to each other. So those controls that are similar are easy to integrate. But the real challenge is when those frameworks are different and you need to be compliant to both of them. For example, with GDPR and PCI, some of the log retention policies that you need to have sometimes conflict with one another, as well as our own privacy policies in the country. So that sometimes can cause some arguments amongst various compliance and legal people.
Great. Any other questions from the audience? Thank you so much, Jared.
Thank
Great
you.
presentation.
Thanks.